Now we'll see how to find out the principal traces by analytical method and graphical method. This is the given problem. First observe the problem. This is a two-dimensional plane and there are the three traces acting on this plane. Two stresses acting in a mutually perpendicular direction. In x direction 50 Newton per m square tensile stress, and in y direction 50 Newton per m square in a compressive nature in a y direction, and tau is a 20 Newton per m square. Newton per m square. Now first we will solve by the graphical method, that is called as a Mohr circle method. Then we will solve it by analytical method. So to solve graphical method, first write down the given data. From above problem we can say sigma x equal to plus 50 Newton per m square, sigma y equal to minus 15 Newton per m square, minus because nature of that y direction stress is a compressive, and value of tau is 20 Newton per m square positive because it is a anti-clockwise direction to the vertical face, and theta is 25 degree. This is the angle of oblique plane with a vertical plane. Now to draw the Mohr circle, first draw the x-axis and y-axis. We are going to plot sigma, that is normal traces on x-axis, and shearing traces on a y-axis. So first we'll mark distance sigma x from the origin, that is 50 Newton per m square. So we'll mark here OA equal to sigma x. And for this particular problem we will take a scale 1:1. Now sigma y, sigma x and sigma y we are going to mark on a x-axis because these are the normal traces, right? And this sigma y is a compressive in nature, so that is a negative. So here we are going to mark 15 Newton per m square behind this origin, or we can say in a second quadrant, and this point will be the B point. Now shear stress is given 20 Newton per m square, and that is a positive. So mark 20 Newton per m square tau from the A point, that is positive tau, and from B, that's B point is indicating the horizontal face, A point indicating the vertical face. From B point also mark 20 but in a downward direction. Then join this A, let it be this point is a P, or sorry R, and this point is a S. Then join this R and S point. For the intersection point give the name C, that is the center point of a Mohr circle. Now to complete the Mohr circle, take a center as a C, or radius equal to CR or CS. This is called as a Mohr circle with a center C. Now see that Mohr circle intersect to the x-axis at the right side or left side. For the right side, give the name P. For the intersection point, give the name P. And for the left side, give the name Q. Now, this is the angle 2 theta P1. 2 theta P1 means this is the angle of major principal plane with a reference plane. This CR is our reference plane. This is a vertical face is our reference plane. Now, inclined plane is given at a 25 degree to the reference plane, that is a vertical plane. Now that angle is 25 degree with the reference plane. This is our reference plane, and this angle is a clockwise angle with respect to reference plane. So we are going to rotate this reference plane by 50 degree in a clockwise direction. Please note that in a Mohr circle we always take angle double. Means if theta is given 25 degree, here we are going to mark 50 degree. So this is our D point. Then draw vertical from this D point up to the x-axis. For the intersection, give the name E. Then join this D to O. This OD distance is called as a sigma R, and this angle DOA angle is known as the angle of obliquity. Now we'll see the various notations. OP means sigma N1 or sigma 1, major principal trace. So mark distance, major distance OP, that is 59, and scale is a 1, so multiply it by 1, 59 into 1, so that value of 59 MPa, or we can say 59 Newton per mm square. Then measure distance OQ equal to sigma N2 or sigma 2. Measure the distance OQ. Now this distance is OQ distance. That distance is equal to 21 into square, 21 MPa. Now measure sigma n. Now sigma n equal to O to E distance is called as a sigma n. Measure that distance sigma n. The distance is a 56 into scale, so we'll get here 56 MPa. That is a normal trace. Then measure D, that is sigma T, equal to, measure the distance, this vertical distance D to E, that is 12 into square, 12 MPa. Then we need to measure here angle of obliquity, that is phi. That angle of obliquity is 12 degree. Phi equal to 12 degree. we need not to measure, or we need not to take it as twice, because this angle is made with the origin, and we draw the Mohr circle with the center point C. So these are the entity which we need to find out according to given problem. Now same values we will find out by the analytical method. We'll take same problem. Sigma x equal to 50 Newton per mm square. Sigma y equal to 15 Newton per mm square. Then tau 20 Newton per mm square. Now to find out principal traces analytically, formula for sigma n is equal to sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 cos 2 theta plus tau sin 2 theta. Now we know the value of sigma x. Sigma x value is 50 Newton per m square. Value of sigma x is a 50 Newton per m square. Value of sigma y is a 15 Newton per m square, but value is negative. And tau is also positive, that is 20 Newton per mm square. Now put the value of sigma x, sigma y and tau in above equation. So we'll get the value of sigma n. The value of sigma is 55.13 Newton per mm square, or we can say 55.13 MPa. Similarly, we'll write formula for the sigma t. Now sigma t equal to sigma x minus sigma y by 2 into sin 2 theta minus tau cos 2 theta. Now put the value of sigma x, sigma y, tau and theta. So in this way we will get the value of sigma t equal to 12.04 Newton per mm square. Then third entity, that is sigma n1, or you can say sigma 1. Formula, this is the major principal trace. Formula for this sigma x plus sigma y by 2 plus under root sigma x minus sigma y by 2 bracket square plus tau square. Now just put the value of sigma x, sigma y, tau, will get the value of major principal trace. So here we got the value sigma 1 equal to 55.61 Newton per mm square. Then 4, that is minor principal trace, that is sigma n2 or sigma 2. Now formula is sigma x plus sigma y by 2 minus under root sigma x minus sigma y by 2 bracket square plus tau square. Now similarly put here value of sigma x, sigma y, tau and calculate sigma 2. So in this way we will get the value of sigma 2 equal to 20.66 Newton per mm square. And to calculate the angle of obliquity, use equation tan phi equal to sigma t by sigma n. Already we calculate the value of sigma t and sigma n. Just put the value of sigma t and sigma n. So finally we'll get the value of phi equal to 12.13 degree. So in this way we can solve the, or we can find out the principal traces on a 2D element which is loaded by the normal traces and shear traces by analytical and graphical method.